All right, you guys, I just wanted to do a quick review over the 4 topics that are on your checkpoint or your quiz today. Here's a list of those topics. The first one is just one question on transformations, right? Shifting, left, right, vertical stretching, that kind of thing. And then the last 3 are ways to solve quadratic functions. So we're solving by graphing, factoring, and square rooting. We still have one more yet to learn, but we'll get to that tomorrow. So here we go. I'm just going to run through at least 1 or 2 questions of each type. So hopefully you'll feel pretty prepared for your quiz today. All right, so you'll notice on this first one, we're going to talk about transformations. And transformations, of course, are happening on our parent function, which is y equals x squared. So there's our little embedded x squared. And you can see we actually have 4 different things that have been added to the parent function, which means we have 4 transformations happening to our parent function, right? So the negative in the front tells us something. The 2 multiplier in the front tells us something. And then the +3 and the +4 are doing something to our parent function as well. So on your quiz, you'll pretty much be asked to write down what those things are. So I'm just going to run through those really quick. So hopefully you guys remember a negative multiplier in the front, right? That is a reflection, right, over the x-axis because we're negating the y's, right? Anything that's outside the parentheses is affecting the y's. And if I make my positive y's negative y's, then we flip over the x-axis, which in turn tells me that this graph is going to be opening downward, right? Which we're going to sketch that here in just a second. The 2 multiplier is obviously affecting it vertically in the y direction because it's on the outside. So it's a vertical. And remember, a 2 multiplier means that I'm taking the function and I'm trying to stretch it twice as tall as it normally is. And the effect of stretching something taller is that it gets skinnier, right? So this is a vertical stretch by a factor of 2. And hopefully you also remember us talking about how that affects the over and up movements of the parent function, right? We had this conversation in class. That normal parent function movement is over 1, up 1, over 2, up 4, over 3, up 9, etc., right? Because the function is y equals x squared. Well, if I'm vertically stretching by a factor of 2, that means all of my vertical movements get multiplied by 2. None of my x movements get multiplied, right? Only the y's, because it's a vertical stretch only. There's no horizontal stretching happening. So 1 times 2 is 2, 4 times 2 is 8, and 9 times 2 is 18. So these are our new vertical movements, right? Twice as tall as the parent function movements. Now, obviously that 18 is a pretty big movement, so I'm not gonna be able to squeeze that on a graph, but it just kind of gives you that idea of stretching it twice as tall. All right, then we have that +3 on the inside of the parentheses with the x. So that must be shifting it left or right because that's how the x-axis moves. And remember, when it's trapped inside with the x, it's always the opposite of the number. So we're actually shifting left 3. And then lastly, that +4, it's on the outside of the parentheses. So it must be shifting either up or down. And because he's positive, that is up 4. Now, when I go to sketch my graph, I clearly want to plot the new vertex first, which is clearly -3, 4, because I went left 3, up 4. So -3, up 4 would put my vertex here. And then, of course, I know it's going to be opening down because of the negative. But again, I don't just want to slap points on there, right? I want to use my new movement that instead of going over 1, down 1, like the parent function would do, I'm going to go over 1, down 2. And over 2, down 8, which would put me here. Notice it's a pretty skinny parabola. I'm going to graph his little reflection buddies on the other side since parabolas have a mirror image on the other side. Notice how skinny this parabola is because I stretched it twice as tall, right? So that means that it's going to naturally get skinnier. If my A value was like a half or whatever, then it would be getting fatter because I'd be smashing it half to its normal height. All right, so something to that effect. And you can use Desmos, of course, to check kind of the placement of your graph if you need to. All right. The next one is using graphing to find your solutions. Please remember what solutions are, right? Solutions are your x-intercepts. Okay, I cannot stress that enough, right? When you are solving a quadratic, you are finding his x-intercepts. I don't care about anything else. I don't care about the vertex. I don't care about the y-intercept. I don't care about any other points other than where it crosses the x-axis, right? Remember, those are also called roots and zeros, right? Roots, zeros, solutions, x-intercepts, they all mean the same thing. So essentially, I just want to be able to type this function into Desmos, sketch its graph, and figure out what the solutions are. Now, the first thing I need to take care of course, is when I solve a quadratic function, it needs to be set equal to 0, right? Because I'm trying to find the x-intercepts, which is when y is 0. So I need to make sure that I bring this positive 6 to the other side. And so if I pick up a positive 6 and move to the other side, the only way I can do that is by subtraction. So he's going to become a negative 6 on the other side. So this is what I want to put into Desmos, right, is 1/2 x squared plus 2x minus 6. All right. I'm going to swing to Desmos. And I'm going to type that function in. So 1/2, oops, wow, sorry about that. 1/2 x squared. Let me see if I can type anything incorrectly. There we go. 1/2 x squared. Oh my gosh, I already forgot what my function was. Plus 2x minus 6. All right, so plus 2x minus 6. All right, and you can type in equals 0 if you want to. Actually, no, you can't. You would actually have to put y equals. All right, so now I am going to sketch this graph because that's the whole point. We're solving by graphing. But I want you to notice these gray points. These are all of our landmarks, right? So these are the points that we definitely want to have written down or on our graph so that we can graph a nice accurate graph of our parabola. Okay, I'm going to write those down really quick. Hold on. -2, -8, 0, -6. Okay, so I'm going to go back to my Notability, and I'm going to plot all of those very special points that graph gave me, right? So net 1, 2, 3, 4, 5, 6. So -6, 0. -2, 1, 2, 3, 4, 5, 6, 7, 8. Because we still want accurate graphs, right? We just don't want to slap something down on our paper and it not be accurate. And then 2, 0. So these were the 4 points that Desmos gave me, right? And they gave me the -2, -8 because he's the vertex. All right, so it looks like this. And then it also gave me the y-intercept. And then, of course, it gave me the 2 x-intercepts. And when we say solve by graphing, we literally just mean go find the x-intercepts, and those are our solutions, right? So on my quiz, right, on the little solutions blank, all right, I'm going to write my solutions as -6, 0 and 2, 0. Okay, and I want you to write your solutions as x-intercepts. You could write it as x equals -6 and x equals 2, but technically those are equations of vertical lines. So I'd rather you leave them as intercepts. Okay, and that's it, right? Use Desmos to your advantage there. All right, the next one is to solve by factoring. Well, you guys are awesome at factoring, right? This is what we did all Unit 6, right? Remember GCF, factoring by grouping, right? So you guys were really amazing at this. The only thing you need to remember about solving by factoring is basically like we do when we solve any quadratic, it must be set equal to 0. So I'm definitely going to take this 4x squared equals 35x plus 9, and I want to get it set equal to 0. Now, the other kicker is if I'm factoring, I never, ever want my x squared or my first term to be negative. So the fact that my x squared term is already a positive 4x squared, I'm going to leave him on the left exactly where he is, and I'm going to bring the positive 35x and the positive 9 to the left side of my equation to join him. And the only way to move terms to the other side is by adding or subtracting and doing the opposite. So the positive 35x is going to become a negative 35x, and the positive 9 would have to be subtracted over, and I'm going to get negative 9. Okay, so we're solving by factoring. All right, so our equation is set equal to 0. Our x squared term is positive. We totally want that. We're also in standard form. Notice ax squared plus bx plus c, right? So we have it perfectly set up for factoring, and now we can get to it, all right? So we're back to what we did all unit 6, right? So we multiply our a times our c. That gives us negative 36. And you can set yourself up a little number puzzle if you liked doing that. So we're looking for the only two numbers in the universe that multiply to give us negative 36, but add to give us negative 35, right? That B term in the middle. And it looks to me that the only numbers that are going to do that are negative 36 and positive 1. And again, you can use your y equals to go find those, right? Remember that? All right, and so let's see, that is going to give us, I'm going to split my negative 35x into negative 36x plus 1x, and then I'm going to bring down my 4x squared and my minus 9. So I've totally turned my 3 term back into his original 4 term, and now I can factor by grouping. So I'm going to split it down the middle, and we're going to do GCF, GCF, GCF by 3 times in a row. So it looks like on the left side, I can take out a 4x, which is going to give me x minus 9. And then the only thing our x and 9 have in common is a positive 1, right? And if I just take out the positive 1, I get x minus 9. Looks like our parentheses are the same, smiley face. That's exactly what I want to see. Now we're going to take out the GCF of x minus 9. And our leftovers are 4x plus 1. And this is where we would have stopped in unit 6. But in unit 7, I still have that equals 0 to bring down because I actually want to solve for x. Right? And so we do that by taking each factor, x minus 9, and setting him equal to 0. We're also going to take our 4x plus 1 and set him equal to 0. And then we solve these little independent algebra equations here, right? And so obviously here we're going to be adding 9, little baby one-step algebra equation, right? So we're going to get x equals 9. And then on this side, it's a two-stepper, right? We're going to subtract the 1, which is going to give us 4x equals negative 1. And then we're going to divide by 4 on both sides. And that's going to leave us with x equals negative 1/4. And those are our two solutions. And you can either write that as x equals 9. I'm totally fine with you leaving it like that. Or if you want to write that as 9, 0, because technically we are finding the x-intercepts just like we did in the graphing problem above. So either way is totally fine with me. I'll take it either way. Okay. All right. Same thing on our x equals negative 1/4, right? Or negative 1/4, 0, right? If you want to write it like that, you totally can. Now, if I were you, I would totally, because I'm going to let you use Desmos on your quiz, so you can totally check those answers in Desmos, right? By simply graphing you want to graph this guy though, right? The one that's where everything is on one side. Put that into Desmos and then just go click on those x-intercepts and see if it tells you 9 and negative 1/4, which would obviously say negative 0.25 on Desmos. Now, the only kicker is your answer is only worth a couple of points. On your quiz, I will be checking this step, this step, this step, this step, this step, and then your final answer. So all of this is worth, you can see, 5 times as many points as just getting the answer written down. So if you just go to Desmos and you just plop your answer, you're only going to get 1/6 of the points for that problem, right? Because I'm checking that you're solving by factoring, not that you can type it into Desmos and give me the answer. Okay, so make sure you're showing all your work if you want all the points. All right, I wanted to go ahead and throw an example on here about solving by factoring when it only has two terms. Again, it needs to be set equal to 0. Now on this one, we want it in standard form, but I always like my x squared to be positive. So I'm actually going to take my x squared term because he's negative, and I'm going to add him to the other side. All right, so I'm going to make him a positive 10x squared over there on the right side, because I always like my x squared term to be positive when I'm factoring. Okay. All right, so now I'm going to solve this binomial. Remember, there's only two ways to solve a binomial, right? It's either it got a GCF, question mark, or it's a difference of two squares, diff two squares, right? These are the two ways that we can factor a binomial. Obviously, it's not a difference of two squares because 10 and 45 are not perfect squares, right? But there is a GCF. So I am going to factor out the GCF, which is 5x. And then that leaves me with 2x minus 9. And then I'm going to bring down my equal sign. And the cool thing is we're done factoring. So right now we're at that step already, right? So once we're factored, we take each factor. Remember, 5x is one of our factors because he's a GCF. We set him equal to 0, and we set 2x minus 9 equal to 0. And clearly, if I divide by 5 on both sides to get the x by itself, 0 divided by 5 is 0. So 0 is one of our solutions, right? Or I would take 0, 0, since that would be the actual coordinate, right, of your x-intercept, right? Either one is fine with me. And then, of course, 2x minus 9 equals 0. That's a little two-step algebra equation. So we're going to add the 9 to the right-hand side. So that'll give us 2x equals 9. And then when we divide by 2 on both sides, that's going to give us x equals 4.5. All right, or of course you could write that as 4.5 comma 0 if you want to write it as a coordinate. Okay. All right. Close that. All right, so that's factoring by grouping. Again, make sure you show all your steps of work, right? Don't skip steps, right? I want to see every step, because if you skip a step, you're probably going to lose points, okay? All right, and then our last topic that's on the quiz is solving using square root method. So remember the square root method, we just did this recently. The square root method means to isolate the x squared, because you'll notice up here on these problems, I have an x squared and an x term. An x squared and an x term. So when I have an x squared and an x term, I can't solve by square rooting, right? Square rooting is particularly when I only see a single x term, whether it be an x squared or an x, it doesn't matter. As long as there's only one of them present, I can solve using the square root method. So your job is literally to move everything to the other side to isolate that x squared. So we just solve it like a normal algebra equation, right? So on this guy, we're going to add 17 first. You always move the constant first, right? And so that's going to give us 2x squared equals, and that'll give us 180. Let me just scooch that guy over there. There we go. All right, and then of course we want to, don't square root yet, because you have not isolated the x squared, right? So you have to move that 2 multiplier next, right? So we're going to divide both sides by 2, and that's going to give us x squared equals 90. Now we can square root, right? The opposite of squaring something is square rooting, right? So we're going to square root the left side. We're going to square root the right side. Good enough. Square roots and squares cancel, and that's how we get that x by itself. So x is plus or minus the square root of 90. Do not forget your plus minus. Remember, every quadratic has 2 solutions, right? And that's how we get them. Because remember, this is asking us what number squared gives us 90. Well, there's a positive number that we can square to get 90, but there's also a negative number that we can square to get 90. So you're responsible for accounting for that. Now you're also responsible for seeing if you can simplify the square root of 90. Now that's clearly not a perfect square. You can try to type that in your calculator, but it's irrational, meaning if you type it in your calculator, it is a never-ending decimal that goes on forever and ever and ever. And we don't want to round that, right? We want to give exact answers only, which means we're going to go off to the side and we're going to do a little factor tree for 90 and see if there's any pairs in there that we can take out. Well, there are, because 90 is 9 times 10. 9 breaks down to 3 times 3. And I like to circle my primes, as y'all know, when we get to the end. And 10 is 2 times 5. Now, there's other ways to get 90, but it doesn't matter. Every single, excuse me, every person that breaks down the 90 should always end up with a 2, 2 3s, and a 5, no matter what. Then we ask ourselves what we have pairs of, and we clearly have a pair of 3s. So remember, you got to have a buddy to leave the house. So the fact that we have buddy 3s means that a 3 gets to come out, but the 2 times 5 has to stay inside, and they just get multiplied back together to stay inside the house because they didn't buddy up. And those are our 2 solutions for our quadratic. Now you can check it in Desmos if you want to, right? But if I go to my calculator and I type, I'm just going to tell you this really quick. If I type 3 root 10 into my calculator, I get 9.48. So let's say this is like 9.48, blah, blah, blah. Decimal goes on forever. And then I'm also going to get negative 9.48, blah, 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 blah. Right? So this parabola is going to look like this. And if you check it on Desmos, Desmos doesn't do square roots, right? So it's going to give you the rounded decimal a number. But you could still use Desmos to check your work if you want to. You're just not allowed to give me decimal answers. Okay? All right, let's tackle one more of these really quick. Now this one is, it's kind of the same thing, right? We have an x term. Here's our x squared is actually right here, right? But we're going to do everything we can to get the x isolated, or the x squared isolated, just like we did on the last problem. Okay, so here we go. You always want to move the constant first, so we're going to subtract the 8. All right, so let's see, that's going to leave us with the 3 times x minus 6 squared, right? And that's going to equal, what, 216? All right, and then we're going to get rid of that 3 multiplier next. Oops. So we're going to divide this entire side by 3. All right, so the 3's cancel. And that's going to leave us with x minus 6 squared equals 72. Right, but now we're trying to get to that x, but we can't because it's trapped inside a set of parentheses, which means now we have to square root, because you can't unlock those parentheses until you get rid of that square. So now is the time where we're going to have to square root both sides. Right, and so square roots and squares cancel, and voila, that allows me, oops, I don't need my parentheses anymore because now all I have left is x minus 6, so there's no need to have the parentheses. And that's going to equal plus or minus the square root of 72. Do not forget the plus minus. Now, you can either simplify now or you can simplify later. I'm just going to go ahead and I'm going to simplify right now. So I'm going to take this 72 right here, and I'm going to go off to the side and make a factor tree and see if I can simplify that, because it's definitely not a perfect square, right? So let's see. That's going to be 2 times 36, and then 2 times 18, and then 2 times 9, and then 3 times 3. And again, there's a little shortcut to this, so if you're really great at your squares, then you don't have to go all the way to the 2s and 3s. If you don't know what I'm talking about, then don't worry about it. So I'm going to take it all the way down to the primes, and I'm going to see what I have pairs of. So it looks like I have a pair of 2s, so a 2 gets to come out, and I also have a pair of 3s. So a 3 also gets to come out, which means what I have now, if I get to take out a 2 and a 3, they get multiplied together. That gives me 6. But then I still have this little lonely 2 that didn't buddy up. So he stays inside the parentheses. Okay, so that's just my next step, was to simplify my radical. And then I'm almost done, right? I just need to add that 6 over to get that x by itself. So x equals, now I'm going to put that, these are not like terms, right? Please don't add these 6's together. This is a 6 root 2 term, and root 2 terms can only be added to other root 2 terms, right? This is a constant. He can only be added to other constants. So these are not like terms. So my final answer is going to be 6 plus or minus 6 root 2. And please put the 6 in the front and not at the back. When we have square roots, we always want the square root to be the last thing in our answer, so there's no confusion. All right, so there you have it. A quick little review for your quiz. I hope you guys do a great job. And please remember to use Desmos to check your answers. But don't forget to show me all this beautiful work, because it's actually the method and all the work that I'm checking, and not necessarily, I mean, do I want a correct answer? Of course I do, right? But I really want correct steps that lead to that correct answer. Okay, so don't forget to show those. All right, good luck, you guys, and I'll see you soon.